Let's show you how to use. Go ahead and fire it up if you haven't already. If you don't have still normal, I'll get to you after class. And then we'll see how it ties to human pregnancy. We'll see how it ties to IQ. We'll see how it ties to Tower of Terror. We'll see how it ties to speed limits. We'll see how it ties to die rules. Oh my God. Oh, sweet Jesus. But we first have to know how to use the Phillips head screwdriver, which is the normal. Okay. Oh, Austin, can you kill one of those lights if you don't mind? Thanks, sir. Check the... Perfect. That's it. That's perfect. Thank you. Okay, here we go. Focus. Now, back in the day, all of this was wrapped up in what are called normal tables in your textbooks, and I discovered this is a much more logical way of doing it. So program, stun normal. What does STUN stand for? Standard. This will not do general normal calculations for you. Why? Because I'm a bastard. No. Because this will be the Phillips screwdriver that you then use. If I gave you a JUT normal, that would be like giving you the cabinet versus giving you the tools to make the cabinet. You ever heard the phrase, give a man a fish, eats for a day, teach a man how to fish, eats for a lifetime? I'm teaching you how to fish. We will start fishing on Thursday, okay? But we're learning how right now. So the normal, boom. Now when you run it, the very first thing it asks you is the type of problem you want to do a forwards or a backwards problem? These are terms I made up. Because the chart that you have in front of you in textbooks has more, I think, confounding terms originally. Here's my definition of a forward problem. A forward problem is one where you have z-scores or a z-score, and you want a percentage or a probability or an area or something like that. That's what I have defined to be a forwards problem. Every problem we've done today, with the exception of those percentile problems, were forwards problems because we had a z-score on the bottom, and we then translated it up and got an area off the chart. And guess what a backwards problem is? Exactly the opposite of that, yes! That's when you have an area or a percentage, and you want the z-scores. That's why percentile problems are backwards problems. What's the 85th percentile? Well, you just gave me the 85th percent. That means I now have to know what z-score does that. I want to show you a couple of each before we walk out of here today. We can use them on Thursday. And next week you'll have a quiz that's just writing this program, which will be super fun. Just simple blow through. Okay, let's grab a forward one first. Let's actually redo some of the problems we've already done today, if that's okay with you guys. So the first one we did was actually a throwback question, wasn't it? I said, what percent of the curve is between -2 and 2? So let's do a between problem first. Between, left bound would be -2. Right bound would be, you press enter each time, +2. Press enter. It's going to draw you a curve. It's going to shade it for you. And then it's going to tell you the area. Notice it's not exactly 95%. That's because it's not exactly 95%. It's closer to 95.5%. The actual z-scores that you would... Does anybody know the actual z-scores that make the closest to 95%? It's... Okay, don't worry about it. I'll do 2.4. Don't worry about it right now. 2 is good enough. 2 is good enough. That's close enough to 95%. It's also hardly out of focus. I apologize. Oh, God. There we go. Much better. So there's 2 standard deviations. There's your 95%. Everybody got it? There's your area. Boom. Press enter again. It asks you what you want to do. You want to do some more probabilities? Hell yeah, you do. Let's do 1 standard deviation. Yes? I sense the excitement. Yes. Forward. Between. Left bound. -1. Yeah. Right bound. +1. It's going to draw you a curve. It's going to shade you 1. It's going to come back and tell you it's about 2/3, 68%, 68.25%. Please, Rory.
Why was the original one, like at the bottom, it kind of curved out a little bit on the shading?
It curved out
Like it didn't.
Oh, is it because my damn screen's not, I don't think my screen's, it's trapezoidal, not rectangular right now.
It did on my calculator
It
too.
curved, what
Like,
curve out?
Just at the very bottom, like instead of having a straight cut down like on -1 and 1, it kind of like towards the bottom, it kind
Is
of
yours
like,
on a 2?
half by step to like.
Oh, you mean the little tick mark isn't quite there? I guarantee it's a pixel problem and not a mathematical problem, Roy. It's because the mathematics being done on this thing is freaking awesome. Unfortunately, it's hidden behind 1982 technology.
I gotta go back and do the other.
If you would, please. I think, was it the -2 problem?
Yeah.
We'll come back to that. Because one of the next things I asked you to do was, what's the area between -2 and 0? Remember that one? Remember that one? It's when Austin said, duh, it's 0.5. I'm like, wait, let me rephrase the question. How about from here to here? We said that was 47.5, right? Now we know it's going to be a little bit more than that, but let's run it again. More props. Forward, between, -2. Let's see if it happens here, Rory.
No, I think I just.
It's okay, brother. Here it comes. Shading, shading. Stops at 0.
Yeah, it's just a tick mark.
It's just that right there, that guy right there.
Yeah.
That's all that is to take mark. Just ignore it. Just ignore it. Look at that. That's damn close to our 47.5, isn't it? Yeah. That's our 47.5 that we said it was earlier. So you see, all the areas we need to get up here can be gotten in here. We also asked, one of the next questions I asked was, how about -2 down to infinity? Yeah? What was that? Now we figured out it was 2.5%, yes? But you can use this to do that as well. Would that be a forwards or a backwards if I said -2 down to infinity?
Forwards.
Dissension among the ranks, I love it.
Be forward to the other Z score.
I still have the Z scores, and I want the area, so it's still forward. It still is definitely forward. If you have the Z's, then you want the areas, it's always going to be forward. So, which way am I shading? It's definitely forward. You're shading left. And the reason I call these left and right, it's mathematically left and mathematically right, if you will. Or, excuse me, not mathematically, logically left and right. So -2 down to infinity, you would actually draw into the tail. Right, you would draw into this tail. Does that make sense? So going left, the right bound would then be -2. Because you'd start at it and then you'd shift to -2. -2. Here's going to draw it for you. Little tiny little area down there.
And left bound assumes negative.
It assumes negative infinity. If you look, this the code for this program, FYI, don't go into it. There it is. And right about there is where it was paused. Here. That's infinity on a TI-83. I coded it in for you, so don't worry about it. 10 to the -99th power is infinity for all intents and purposes on a TI-83. So please, don't ever do what I just did. If you do, I'll fix it, obviously. But it's safer just to let the program run itself. Please, Natasha!
Is this like the only graph that you can check the area on with? Or can you
Yes!
check the graph?
Hold that thought. You thought like the IQ graph and everything else? Good. I called this stun normal. It's only standard normal because I want you to focus on Thursday on the conversion back and forth between an IQ curve and this one. And we're going to use Mark Spitz and Michael Phelps to talk about this. Natasha asked a very good question. Is this the only bell curve this program does? Yes. Because you are going to be confronted with lots of bell curves in your statistics practice, whether it's your research, whether it's Math 244, whatever, Math 245. This gives you a tool to pull in the areas, but you have to know how to convert back and forth. Go ahead.
If you had like the y equals the formula for a different curve, could you plug it in?
You actually, if you wanted.
But like,
There
would
it
it
is.
have to be in the coding or what?
Well, there's a command called normal CDF that I'm using, but this is the equation it's using. There. That is if you graph that, you get this shape.
Okay.
Now you can mess with that shape by putting in different U's and sigmas, which we're going
Yeah.
to start doing on Thursday. But that's how you would actually graph it, for sure.
Okay.
If you want to. Most of you are going to look at that and dry heave a little bit, so we're going to stop talking about it. Just realize that when you run this, it's doing that for you. Fair?
Yeah.
Good, good. And there's some neat mathematics there too, but we'll worry about that later. Now, I want to close with some backwards problems, yes? Some backwards problems. Remember how we asked about what percentiles certain z-scores were? Okay, so let's do a backwards problem. Let's focus on percentiles right now, which always shade to the left. They always shade left of the curve. Okay, let's answer Austin's first. So, what percent, when I ask the question, if I cut the curve in half, what area shaded? He said, half. You just said the answer. Okay, let's say I forgot that, and I put in 0.5 for the percent. If I shade 0.5 to the left, where do I stop shading? I stop shading right there at 0. You've now shaded half the curve. You've now shaded half the curve. Fair enough? My next question was, what percentile rank was that 2 that was out there? Okay? So if I didn't know the answer to that, if I knew the percentage but didn't know that, I knew from our previous talk that we thought it was at 97.5%, right? So if I asked somebody what the 97.5th percentile was, the 97.5th percentile was, watch this, it's going to shade 97.5% of the curve. Notice it doesn't go all the way out to 2, it goes out to 1.96, which is actually closer to 97.5. 2 is a little too far. 2 picks up a little bit extra air. Does that make sense? Hopefully. Mathematically, statistically, it makes no difference at all. You can call it 2. And this, I'm going to leave with one question that somebody asked in the last class. They said, okay, Rule, I know that Q2 or the median is 0, right? Q2 or the median is 0. Their next 2 questions were, where are Q1 and Q3? So that's my question to you guys. Where is Q1 on this curve? Over here somewhere, yeah? But where? Let's just, here's Q2. I want to start moving. You tell me where to stop. Oh, let's do that again. I'm not hearing very many votes. Usually you guys vote as a unit. Stop! Q1, which means Q3 is going to be over the same distance this way, right? So what we've just done is we've separated the curve, if we do that, into 4 equal pieces of how much each? 25%, 25%, 25%, and 25%. My question is, we know this is 0, yes? What's that right there? Guesses? Good! You've had enough. It's getting close to the end. Let's figure it out. Let's figure it out. A backwards problem. Let's shade to the left, and let's cut off 25%. And let's see. First of all, see how well we did. Oh, you guys aren't bad! You went a little bit too far left, but not bad at all, guys. Negative 0.67, negative 2/3 of a standard deviation.
Yeah, I want to be
Which would be positive 2/3 over here for this one. Negative 2/3 of a standard deviation, positive 2/3 of a standard deviation. You guys, if you guys did the Chebyshev quiz weeks ago, you actually had to know that. You had to know that negative 2/3 was actually half and half. So, but you probably forgot it too, which is totally fine. We'll come back to it on Thursday. Okay? Your brains are full. Go and enjoy the sunshine wherever you're going next. Take care of yourselves. Thank you for all the questions, Rory.
The program, every time I got into it, I have to clear it out.
Turn off any graphs you have on. Start with that. It still doesn't reload it on Thursday, okay? Cool? Yes! Yes! So you guys, could somebody close the camera? Don't mind, guys? Let's share for sure.